find the slopes of the lines which are parallel and perpendicular to this given line. Well, I'm going to begin by putting this given line in slope-intercept form. I want to subtract the 3x off of each side, so we're going to have negative 3x plus 18. And dividing by negative 7, we're going to get 3/7 x minus 18/7. Notice it became positive 3/7 because we had negative divided by negative. So the slope of the parallel line to this would have a slope that's the same, 3/7, and the slope which is perpendicular to this given line is going to be the negative reciprocal, so we're going to change the sign to a negative and flip the fraction over and have negative 7/3. Now, the following problem piggybacks on this problem. Rather than finding just the slopes, it says find the equation of the line that is parallel to this line and goes through this given point, and then perpendicular. So for part A, let me slide this upwards, we've already found up above that the slope is 3/7. So for part A, we're going to use the slope of 3/7 along with the point they're asking us to find the line through, negative 2, 4. We're going to use this point slope formula, which we used a moment ago. Y minus y1 equals m times x minus x1. And we substitute in these values that we have right up above here. That gives us y minus 4 equals the slope of 3/7 times x minus a negative 2, which becomes x plus 2. And then we're going to do the distribution to convert this into slope-intercept form. We're going to have y minus 4 equals 3/7 x plus 6/7. We then want to add 4 to each side of the equation. On the right, I'm going to add this as a 28/7 because I need a common denominator of 7 in order to combine these values. That's going to give us the final answer here of y equals 3/7 x plus 34/7. Now that's the answer to the parallel portion of this problem. Then it asks us for the same thing to be done all over again where we have a perpendicular line. So this time we're going to use what we found up in the previous problem, the slope of negative 7/3 along with this point negative 2, 4. Now I don't want to rewrite that point slope form because I've already got it sitting right there at the top of the screen. I'll go straight to substitution. We're going to have y minus y1, that's y minus 4, equals negative 7/3 times x minus a negative 2, which becomes x plus 2. The only thing that differs between the last problem and this problem is what slope I have substituted in. At this point, we're just going to finish off this equation. We're going to begin by doing distribution on the right hand side. The left side is going to remain y minus 4, and the right side becomes negative 7/3 x minus 14/3. We're going to then want to add 4 to both sides to isolate the y by itself on the left. On the right, when we add, we want to keep a common denominator of 3. So 4 over 1 here is the same as 12 over 3. So finalizing this problem out, we're going to have y equals negative 7/3 x minus 2/3. On Alex, those two parts A and B together are one problem. Problem number 9 here, we want to find the x and y intercepts. That's basically what we're doing when we graph using intercepts. So I'm going to do the same thing here. If I let x be 0, basically I don't have that 4x there anymore. I just have negative 9y equals 13. So dividing by negative 9 on both sides gives us negative 13/9. And that right there is the y-intercept. If we let y be 0, we're going to get the x-intercept. Substituting 0 in for y here, zeroes out that part of the equation. We have 4x equals 13 left. Dividing each side by 4 gives us 13/4. So I'm kind of saving some space here. It's really 0, comma, negative 13 ninths, and 13 fourths, comma, 0 as the y and x intercepts.